Okay, we're gonna go over some problems, and then I'm gonna lecture you on both the washer and the shell. We got people missing from class, and then by Friday, people in the musical, then I think will be barely awake yet. So, we gotta get things done in the beginning. Okay, so last night's homework, you have to do discs. Why are there so many questions? 15. Okay, we will answer questions until for like 10 more minutes. If we don't finish, we'll get to them tomorrow. Look, this problem, they give you everything, Louis. Look, x equal, once you see x equal, it's kind of like telling you I should do horizontal rectangles, and look, they draw in the horizontal rectangle for you. Anyway, it says revolve it about the y-axis. So if this rectangle gets revolved about the y, are you guys good at drawing the disk yet? Not even I'm good. That's not good. Okay, so what's the formula for area of a disk? Pi times the radius squared dy, since the rectangle is horizontal. Now look at that picture. What is the radius of that disk? How do you find the length of the rectangle? The radius is always going to be the length of the rectangle. So it's either top minus bottom if it's vertical, or it's going to be right minus left if it's horizontal. So in this case, right minus left. Because the equation of the y-axis, isn't it x equals 0? Yeah, so what's right minus left? Yeah, just tangent of pi over 4y. You guys just don't like the horizontal rectangle. You got to get used to it. And then add up all of these disks from 0 to whatever the y coordinate is up there. Do they actually tell you in the picture? Yup, 1. Now, do I actually need to do this integral, Suzaki? No. Throw the pi on the outside like an unwanted pet, and then you got tangent squared. What's the only way in the whole world you can integrate tangent squared? No, you have to replace it with the identity secant squared minus 1. That's the only way. It's on the list. Okay, so you got pi. What's the antiderivative of secant squared box? Is it just tangent box? See? Even Louis knows. Now what do I put in the front? The reciprocal of that number. Because when you take the derivative, you got to multiply by the derivative of box. Just like if that was a 2, what did you put 1/2 in the front? So if you have gorilla, then you put 1 over gorilla in the front. It doesn't matter what constant it is, just put the reciprocal in front. Minus, what's that antiderivative of 1?
Y.
It's y. How come it's not x? Because you're integrating with respect to y. It's dy. See, some of you, you know, the dx, the dy at the end, it actually means something, you know. I will let you plug in the numbers. I'm not gonna. You just think I'm a pushover. I think I'm gonna do everything for you, yeah? Here, wait. Let me finish this off for you. I'm not gonna do it. I'm not gonna finish. I don't care what you say. Oh, I remember this problem. I checked it last year. You know why? Because it's even. Many people got this with -5 off the homework. Okay, I take this. What kind of rectangle should I draw? Yeah, horizontal, vertical. You know why? Because it's y equal. Anyway, if you attempted to draw a horizontal rectangle, you revolve it about the x-axis. That's a shell, right? The rectangle determines whether you're going to have a disk, washer, or shell. If this thing gets revolved about the x-axis, you get a disk. Everything on last night's homework was disk. The formula for the disk? Pi times the radius squared dx. It's just a circle times the thickness. Okay, now what's the radius of the disc right there?
Sine x,
That
cosine
is
x.
spot on. So it's just sine x cosine x. Add up all of these from ring 0 to. Is that pi here? Does the book tell you? Let me look. The book doesn't tell you. It's pi over 2. That's what I got, Kimo. No, she's right. No way! This is review! It's a stab in the back.
It's like a black man and a black girl.
You guys know why it's pi over 2 and not pi? Because cosine of pi over 2 is 0. And pi over 2 is smaller than pi. Okay, do I need to do this integral, Suzaki? Oh, Suzaki. How are you doing that? Okay, I'll do it. Okay, pi over 2. So we have sine squared x times cosine squared x dx. Can I do u substitution? Because this is obviously not on the list. U substitution? No. Okay, what then? U equal what?
Cosine squared x.
Sorry. The derivative of cosine squared x would be 2 cosine x times negative sine x, and that's not that. Nope, u substitution doesn't work.
Could use the identity
Yeah,
from sine 2x.
exactly. That's the only thing you can do. So replace this with the identity 1/2 minus 1/2 cosine 2x, and replace this one with the identity 1/2 plus 1/2 cosine 2x. Multiply them together. What do you got? 1/4 minus 1/4 cosine squared 2x. And again, what's the only way you can integrate cosine squared? You got to replace it with the identity 1/2 plus 1/2 cosine 4x. And this is exactly why I tell you don't memorize the integral, memorize the identity, because when it's not just x, you're going to be in trouble, believe me. So if I distribute this negative 1/4 over there, you're going to get, oh, I could have pulled something there. 1/4, distribute the negative, silence, I'm trying to concentrate, minus 1/8, minus 1/8 cosine 4x. And then of course, 1/4 minus 1/8 is 1/8, yeah? You want to factor out the 1/8? Nah, just leave them. So this is what we got, pi times, the antiderivative is going to be 1/8 minus 1/32 sine 4x. See, you guys are just copying. You guys know why? How come there's a 1/32? Where did that come from? Because the derivative of the box is 4, so you gotta put a 1/4 in the front, but there's a 1/8, so 1/32.
Why is it 5/4?
It's not pi, look, it's pi over 2. It's pi over 2. Just look at the video. Because the identity, what's the identity for let's use theta instead. What's the identity for cosine squared theta? 1/2 plus 1/2 cosine 2 theta, right? So whatever this is gorilla, this is 2 gorilla. So since that's 2x, then that's going to be 4x. Yeah, there's an x right there. Just look at the video, guys.
Wait,
Anyway, how come only one person saw that?
I saw it.
Because the rest of you
don't-
just
You don't
copied.
want me to say anything.
Except
Mr.
Taruya not even doing anything.
Park. You don't want me to say anything, Mr. Park.
Okay, we're gonna
Wait,
do
Mr.
one
Park,
more.
Mr. Park, Can you do 1/4 sine 2x squared or something like that?
What?
Can you do one?
That's the only way in the whole world you can integrate cosine squared.
Because isn't that?
That's the only way. There is no other way. Do you guys ever notice that when there's sine squared, cosine squared, tangent squared, or cotangent squared, I always say this is the only way in the whole world. You know why? Because that's the only way. There is no other way. It's mathematically proven. Okay, we're gonna do one more, and should it be 27? And we'll do the rest tomorrow. 27, 29, 49. Which one looks the most juicy? 27, 29. Yeah, 29 is baby food. 49. Where's 49? 49. Come on, 49. They gave you the picture, Suzaki. 27 looks the 27 looks the most succulent. Okay, the region in the first quadrant bounded by the line y equal root 2. Below by the curve y. Now I don't know what it looks like, but I know that if you plug in 0, you get 0, and then it's going to intersect over there. Left by the y-axis, and we're going to revolve it about this line right there. Okay, so first, y equals secant x tangent x. Okay, what is this point right there? Guess and check. Is it pi over 6? Like if I plug in pi over 6 here and here, do you get root 2? Who said yes? The answer is no. Tangent of pi over 6 is 1 over root 3. Come on, there's no way, this is a root 2. Okay, what about pi over 4? Next. Yes, there you go. Because if you plug in pi over 4 here, you get root 2 times 1, which is root 2. So that's your limits of integration, people. Okay, make the rectangle. If I revolve it about the line y equal root 2, I better move it on the side here. You get, oh, what a surprise, it's a disk. And the formula for the disk is pi times the radius squared dx. And what is the radius? What is the length? The length of the rectangle will always be the radius. Top minus bottom. Root 2 minus secant x tangent x. Add up all of these disks from ring. Okay, did we at least get the correct integral? Wait, I'm not done writing. Suzaki, how come you can't write on the board unless you actually try it if you know?
I did try it.
Wait, how do you know it's just Suzaki that's writing on the board?
Because I saw him go up there. Plus, look at that writing. Who else could it be? I know you guys had writing by now, you know.
Even mine.
Okay, now, you want me to compute this integral? Okay, what's the time? Okay, I'll do this and then we're going to move on. You guys got to actually do stuff. Please help me. Please help me. Put the pi on the outside, and you got to multiply this out. So if you multiply this out, you get 2 minus 2 root 2 secant x tangent x plus secant squared x tangent squared x. Did I do that correctly? Yes. Okay, now, this is on the list. This is on the list. Oh, what about this one? U substitution. You should know already. How come? How come U substitution? Because that's secant squared. If you let u equal to tangent x, then that's du, right? Secant squared x. Okay, let's go on the side and do it. What's the integral of secant squared x tangent squared x dx? If I let u equal tangent x, you guys are supposed to be experts at u substitution, you know. You know what? Maybe spring break, I gotta give you a project. Yeah, I'm not, because it's a no homework thing. So I've got the integral of, that's u squared, and secant squared x dx is du, so that's just 1/3 u cubed plus c, right? Okay, so let's put it all together. What do we got? Integral, no, now we're doing antiderivative already. What's the antiderivative of 2? 2x minus 2 root 2, throw on the side like an unwanted pet. What's the antiderivative of secant tangent? Secant plus, and then 1/3 u cubed. But what was u? So tangent cubed x from 0 to pi over 4. I think you guys can handle that, right? All you gotta do is plug in the pi over 4, because when you plug in 0, it's just 0, 0, 0. And we know secant of pi over 4 is root 2 and tangent of pi over 4 is 1. Come on, I just did everything for you. Okay, we'll do the rest tomorrow. No, when do I see you? Thursday. Okay, so I'm going to lecture on, and this is the last, that's it. I'm going to finish it. There's no more lectures after this, you guys just got to practice. Yeah, you can't make me, Mr. Park. I'm a senior.
Yeah, I'm a senior.
Okay, so yesterday we did this, and I'm going to do all three of them over here, just for your viewing pleasure. Okay, so if you draw the rectangle of infinitesimal width, Jaime Escalante at the strip, and it is touching the axis of rotation, if you rotate it about, you get the disk, which is, if we call that r, pi r squared dx, right? And the radius is simply the length of the rectangle taught by its bottom. Okay, now tonight's homework is going to be, no, I think it's good I do both, because lots of problems you can do both ways. That's why. What if you draw the rectangle, it's perpendicular to the axis of rotation, but it doesn't touch? I did this yesterday, people. It's
The
called
washer.
the washer. Oh, that one kind of went off.
Mr. Park, does everyone have to do the washers and shells homework?
No, you just do one homework.
Oh.
Just do one homework. Okay, so why don't we call big R the outer radius of the big circle, the radius of the big circle, and small r the radius of the inner circle. How do I find the volume of this washer? Come on, this is geometry. By the way, what do we call this here? This is a trivia question. In geometry, what do we call this region right here? When you have two concentric circles. This is called an annual. An annulus. Anyway, so the volume of this is going to be the area of the annulus multiplied by the infinitesimal thickness, right? Anyway, how do you find the area of the shaded region right here? Wouldn't it be the area of the big circle minus the area of the small circle? So what's the area of the big circle? Pi big R squared, right? What's the area of the tiny circle? Pi small r squared. And then you multiply it by the infinitesimal thickness, which is dx, because the rectangle is vertical. Now this is it, except what we do is we normally factor out the pi so we can throw it on the side. So tonight's homework, this is what you're going to be using. This is the formula for the volume of a washer. And then I'm going to roll them all together in one. Now, what would happen if the rectangle you draw is parallel to the axis of rotation? Then when you revolve it around, it's not a cylinder because it has a thickness to it, right? We call this a shell. Toilet paper roll. What was the other thing I said it was? Sewer pipe. But the mathematical name is shell. So this is washer. This is called a shell. Okay, now why don't we call the radius of the shell r, and we'll call this height. And can you see the height is simply the length of the rectangle, which is going to be right minus left, yeah? So how do I find the volume of that? It's like a sheet of paper, people. Where's a sheet of paper? Can I borrow this? Here's a sheet of paper. Look, you roll it like this. Look, it's a shell. Right? That's what a shell is. It's a shell. So how do
The circumference times the height.
So all you do is you unfold it. What is the area of this?
Circumference
That
times the height.
which is the circumference times the height, but it has a thickness, and you just multiply it by the thickness. No, it's not dx. It's dy because the rectangle is horizontal. So some of you are for real. You're not going to get it. The rectangle, and for those of you who don't draw the rectangle, you're in big trouble because the rectangle determines what shape you have. Okay, so circumference is 2 pi r times the height, but then you multiply it by the infinitesimal thickness. In this case, it's dy. So this is the formula for the shell right there. This is just on geometry, people. It's not nothing exotic. Or what?
Finish it.
Okay, so let's look at a few examples and we're done. Okay, I'm gonna do problems where like you can do it both ways. So here, so here we got y equal root x. I love to use y equal root x on my quizzes and tests to find out. And here is the line, woo, y equal x over 2. So people, guess and check. What are the coordinates of that point right there?
4.
4, 2. Isn't that a lot easier than just trying to set them equal to each other and solve? See, when you keep doing that, you're going to get better at it. If you just keep copying off the board, you're not going to get good. Look at what you made me do. Okay, take this region and revolve it about the x-axis. Can you imagine what shape that is?
Yeah.
It looks like it's like a vase, yeah? Sideways, except the inside of the vase is like, yeah, it's like a cone, yeah? So people, what? It's like a vase, like that, but the inside is like a cone. Okay, but you really don't need to know what it looks like. You just have to be able to compute its volume, okay? So, which rectangle should I draw? Should I draw in a vertical or horizontal? You can do either. If you draw in a vertical rectangle, and I revolve it about the x-axis, what is that? It's a washer, we just did it. But if you drew the rectangle in this way, and you revolve it about the x-axis, you get a shell. You can do it either way. I'm going to do both for you. Okay, so drawing the rectangle. Anyway, it's better to do it this way. You know why? Because y equals. If they give it to you in terms of y equals, you don't have to do any work. So what you do is you draw in the washer to the best of your ability. Like that. Okay, now what's the formula for a washer again for the kitchen room? Pi times. Just do this every single problem with what? Big R squared minus little r squared dx. And all you gotta do is fill in the parentheses. Okay, the big radius goes from the center of the washer to the outer edge, right? This is big R. How do I find this distance? Top minus bottom. Anytime, look, I keep drawing this picture for you. If this is 2 and this is 5, how do I know that's 3? Top minus bottom.
Wait,
So-
so that's. Oh, yeah.
So if I want to find this, top minus bottom, what is that minus that? Root x minus 0 is just root x. Okay, here's the small radius. How do I find that length? Top minus bottom. X over 2 minus 0. And then you add up all of these washers from 0 to 4 or 0 to 2?
0, 4.
0 to 4 because you're doing the integral in terms of x. So you go from the x coordinate here to the x coordinate there. You get it? So again, we're just adding up all of these things to get the whole thing. Now, Mr. Park, you said you could do it the other way. Yeah. So I draw the same picture. If I revolve it about the x-axis, you're going to get the same shape no matter what, but you can compute the volume in different ways. What if, Mr. Park, I want to draw the rectangle horizontal? Because I like to be different. Okay, well, cool. The only problem is now you got to solve for x. So if you solve for x in this equation, you're going to get x equals y squared. If you solve for x in this equation, you're going to get x equals 2y. And then when you revolve this rectangle about the x-axis, you're going to get the shell. Oh, that's ugly. Okay, now what's the formula for shell? 2 pi radius height d
Y.
y, because you drew the rectangle. See, the rectangle tells you everything. It's the rectangle. Okay, here is the radius of the shell right here. Now, if I don't know why, but students get confused sometimes. So you know what? Whenever you do a shell, you see where the rectangle touches the curve. If you label this point x, y, maybe it'll help you to figure out what the radius is. What is the radius of the shell? It's y. Okay, let's go back to pre-algebra. You know when you first started plotting points in the Cartesian plane? X comma y. Let's say this point is. What is this distance? This is x and this is y. X tells you how much you go this way. Y tells you how much you go that way. So if you label this point x, y, what is that? That's y. Look at that. The y. Mr. Park, how come you're putting y's in here? Because you're doing the integral in terms of y. You gotta have y's in there. Okay, now what about the height of the shell, which is simply the length of the rectangle? How do I find the length of the rectangle if it's horizontal? Right minus left. So which one's on the right? And which one's on the left? So right minus left. See how everything has to be all y's if you do it in terms of y? That's why if you don't have the dx or the dy at the end, it's over. It's all over but the crying. Now add up all of these shells from 0 to 2. If you're doing an integral in terms of y, you go from the y coordinate here to the y coordinate there. Now, if I compute, since we don't have, normally I would compute both of these just to show you they come out the same, but just believe me, they come out to the same number, and don't they have to? Okay, one more and we're done. I'm gonna erase this now. Okay, same thing. Okay, this is the same thing, except revolve it about this line right here. This is the line x equal 4. Take this and revolve it about the line. What is that going to be? That's going to be like a bigger vase, yeah? It's like an upside down punch bowl, except the inside is like a cone, yeah? Okay, I'm just going to do it one way. Because tonight's homework is going to be what? Tonight's homework is washer. So if I want to make a washer, which way should I draw the rectangle? Yeah, you should draw it horizontal. Because that's what's going to give you the washer like this. Okay, so quick, pi big R squared minus little r squared dy. How come I did dy? Because the rectangle is this way. And since the rectangle is this way, you gotta solve for x. X equals y squared. And then, wait, x equals 2y. Come on, we got 1 minute. Okay, big R. Big R goes from the center to the outer edge. How do I find this distance? Right minus left. Which one's on the right? And which one's on the left? 4 minus, it's quite simple. If you're doing this thing, it's right minus left. If you try to find this, you go top minus bottom. Small r, the small radius goes from the center to the inner edge. How do I find this distance? Right minus left, which is 4 minus 2y. Add them all up from 0 to 2 or 0 to 4? 0 to 2 because we're doing it in terms of y. Okay, I'll see some of you on Thursday, yeah? Who's not here Thursday? Love. Well, Friday. Oh, so everybody's going to be here Thursday? Oh. Maybe you didn't have to. What you thought? Okay. Okay, thanks.
You know, tomorrow during meeting